All right, so on the Argo test, and this doesn't really do a great service for you, but trying to show you nomenclature. Remember, when we're naming things, you're responsible for chains and branches, you're responsible for bonds, and you're responsible for functional groups. Branches, remember, besides they could be like a methyl or an ethyl or a propyl. You could also have halides, which is a fancy way of saying halogens. So, for example, F would be like fluoro, just as an example. When we're naming things, I'll talk about what we mean. When I drew this, it's kind of like, well, how much do I have to draw? Do I have to do carbons? Do I have to do all my H's? Do I have to do lines? We'll kind of talk about that. But numbers, prefixes, suffixes, those are all on your pink sheet. But through Argo 3, Argo 2, lesson 33, and the review last night and today, hopefully that's just kind of making as much sense as possible. These are the ways that I am requiring you to draw and or read them. Some of them you'll just have to read it. So just before I get ahead of myself here, this sheet from last night, there are some missing things. So if you watch the video, you'll notice that you have to draw some stuff in here. This was last year's test. I literally deleted the word test and I wrote Argo review on the top. So this was actually last year's test. I'm tired of it. I only did it a couple of, I was changed a little bit, but I want to completely redo it. So if it's condensed, it might look like that. I can give it to you as CH3CHCH. Well, what is that? You have to realize, you have to read through it and realize, oh my gosh, there was a double bond in there. So I could give it to you as a formula. If I ask for all atoms, then that's what I would ask though. So either if I had you drawing it. Now you don't have to draw it with all the hashes up and down, and you could put them next to each other like the thing that I have there. But that's usually a little harder because you have to pre-plan, you have to understand where all the H's would go. Again, that's if I had given you the name and then I say draw it. Lines, it's a zigzag. If I say lines and you draw it with carbons, that's gonna be a problem. And if I'm not in an argument, well, this is right. That's not the test. The test is, can you draw it with the lines? Like, that's what I'm asking for in that problem, besides the fact of getting it right. So please, let's not have some weird power struggle all of a sudden where you think like, well, I'm just gonna do it the way that I'm hoping to do it because I feel more comfortable. Like, you gotta do it the way I'm asking.
Will we have to draw the formula one?
Probably not. I would probably give you the formula and I'm gonna ask you to name it. And again, were you here last night? I can't remember. Okay. I'd watch the video, or at least look through the sheet a little bit. It kind of gives you a good clue. At least, what I would do, at least fast forward through to see what the missing drawings are. I'm sorry, I have no idea. On my screen, it's all there, and then when I print it, the printer doesn't like some of those images. Don't know, because I printed it last year and it worked. And then if I ask just for carbons, all you do is draw carbons. So that could link into, for example, an isomer, where you have to just draw C's, because I want to keep that real simple. Here are some other miscellaneous things that you just need to have down, okay? Cyclos, those are rings, okay? If it's a chain, you end it as an ane. This isn't going to happen potentially, but anything could happen in one isolated problem. If you ever see a YL in general, I'm just trying to throw this out here, like, it's not out of left field here, it's just, oh, wait, cyclopentyl, well, that would just be whatever that is. So let's just say there's some long branch here. Well, that would just be a cyclopentyl. If you feel like, wait, that looks like a branch. A branch would have a YL at the end. The big one, though, for you is the benzene. Benzene by itself is a chain. Benzene either is a circle or the three bonds. I like the three bonds. It's fine, whatever you want to do. When it's a branch, though, it's a phenyl or a phenyl. And that's going to happen. I promise that will happen. And actually, one is not on here. Sorry, I'm going to go back up for 1 second. One other branch, this will happen as well. An iso. What is an iso? When I have a chain and what's up on the branch? Where is that located? What is it? It's on the second carbon, right? So usually, why am I feel like we run into isopropyls a lot? Because the minute you get into an isobutyl, I'm going to put an isobutyl here, but the minute you get into an isobutyl, what happens is as you go through the chain, sometimes this becomes the longer part of the chain, right? I mean, that's what can happen. So a lot of times when our naming, you got to keep in perspective. We're restricted. Even if you feel like there's crazy things to do, I got to go with these. And it's unlimited possibilities. We are really strict in what we can do right now. There's only so much that we're allowed to do with what we have. But know that an ISO might come up. We're going to do one today. And then finally, it's on, oh no, not finally, two more things. You will be required not to name it. I will guarantee you on this. But you should be able to draw a cis or a trans. And there's one on the review from last night. So just remember this. Remember R's, when I draw an R, that means it's a carbon chain. A trans, I think of like transversing. It's a really long distance, so I'm going further. So it's orientated around the double bond below and above the carbon. I mean the bond. The carbons are above and below either side. And a cis is on the same side. So if I say carbons, it'll look like this, or all atoms. And in like lines, it could look something like that. Now, oh wait, you put H's. Yeah, I don't need them there. If I cover those up, it's fine. But a lot of times people put the H's kind of offset, like to feel more balanced. But I hope you just need to come up with, oh, the trans goes on opposite sides of the double bond. The cis goes on the same. It looks like a C. It really does. Last hour, everyone turned their head. I'm like, it's there. You've never seen it. So know that. Isomers, the only two rules, I just want to make sure that you have real, just straight. We're going to do one right away. That's our first example. You always reduce the chain. So start with the longest chain. Reduce the chain. And then the second thing, really important, is never add your C's to the first or last carbons. Because if you do, you're going backwards. You're adding back to the length of the carbon, right? Or the chain, the length. I said it twice. Finally, this looks a lot more complicated than it really needs to be. I'm just being really thorough. So again, if you want to just take a photo of that with your iPad or whatever else, that is totally fine. But reactions. On the back of the review from last night, I give you examples of just, hey, give me a generic reaction. We're going to do two today. But halogenation or hydrogenation, all this is you need to understand, I've given 3 different examples. Like any one of these would work. Any one of these. The only way you can add H is if you have room to do it. So you cannot add hydrogens if there's no space. So how is there space? If you have additional bonds, right? It's the only place. And then they technically would be added on the bonds, but you don't really need to show that because in lines, for example, the H is already there. So here's just 3 examples. One, you have a double bond, it goes to a single bond. If a triple bond, it goes to double bond. And in this case, if it says the word excess, it will go all the way. So just be careful. If it says excess, you have way more than you need, so it will saturate that bond. The other ones that you'll need to know, I'm not going to do combustion tomorrow. I promise that, so that's why I'm kind of leaving that down on the bottom. It is a very common organic reaction, but dehydrogenation should sound the way it is. If I say, show me an example of a dehydrogenation with a 4-carbon chain, that's what it could just say. Okay, well, I need to start with a chain, and then I need to have more bonds than I started with, and I need to have the H2. What if this went from a single, what if it went from this, and then on this side, I know that wouldn't be, let's not put it there, because it would be a straight line, like the lab. Let's say it's this. What would I write there exactly? 2H2, right? So don't get too fancy. Be like, well, can I do that? Yeah, you just took out more H's, but wait, why 2? Because I made a triple bond, so I had to take 4 H's out, right? It's still got to stay balanced. So that's how that could look. And then the last 2 ideas is substitution. On the back of your pseudo test, your review, I said, give me, what's the wording? Like, give me 2 examples of how a carbon bond can react with 2 possible reactions of a 5-carbon hydrocarbon with fluorine. With fluorine. Well, act like that's a halogen. So what you could have done is, if I just said, show me 2 different reactions that could happen with a halogen. One of them could be a substitution. What is a substitution? It doesn't have to go there. It could go anywhere. The I goes in, but only one thing comes out. It's like substitution. You're subbing. So you're not staying there forever, so you make an acid. So if I ever say the word substitution, make sure you realize, oh, I got to make an acid. None of this will make or break your test. But you have it down. And then halogenation is kind of like hydrogenation. It has to be added to an extra bond. It has to be. This one, though, you can get wrong. This one is just, oh, double bond goes to single bond. those had to go there because I put the bond there. Okay, just right. The bond opens up and it grabs those C's. Basically, I mean that's how I always think about it. That's the bonding site. Okay, technically that double bond where the H's are, that's where those would have gone as well. Okay, so I'd suggest having something to write with. We're going to do some problems, and away we go. So I'm going to do a different one today. On your sheets from last night, or the video if you want to watch it, and I actually really strongly suggest, I think that was a great variety of examples. One of them was an isomer, and you will have one. And it's really hard for me to grade, because all of you, you're not me and I'm not you, so how you write things out, it's different. So in case you didn't want to pick one up or you didn't pick one up, on the back I have slots. And it's going to look very similar because this has worked for me, the idea. I give you a certain number, so first off, it won't be more than that. I've had people do that. I did 12, and they're like, but I got 15. But I told you it can't be more than 12, so you can't feel good about that. Like, no, he's wrong. I actually had somebody think, well, you got to be wrong. Nope, stay in the guidelines. But it doesn't have to be 12. In this case, I believe it was 8. So it ranges in there, and that's always the conversation as people are leaving. And it's nice because everyone's going to take the test at the same time. All I hear is as you're leaving, like, what'd you get? I got 9. Oh, I got 7. Oh, no. And then people are all freaking out. Hopefully everybody takes it. If everybody takes it at the same time, I'll tell you how many there are at the end. In fact, I'll probably have to just make another test, so I'll probably tell you anyway. If there's an extra bond, that's not in this case. Why do I know that's not an extra bond here? Because halogens act like hydrogens, like how they bond. So I can act like there's 10 things bonded. So 4, double it, add 2, that's 10. But before we do this, if you had a double bond, just going to make this up for a second. So if this was C4H8, the problem with this is, actually, let's say it's this. I'm just doing this on the side if you want to do this for a second with me. This is the problem. You have one like this, and then you got to move the bond around. So if you get a double bond one, we had this on Argo 2. You can move the double bond. Now, if I move the double bond over here, is that a new structure? It isn't, right? Isn't it the same as this one? But let's say you shrink it now. So once you can't move that bond around, you got to shrink this. This is the problem with double bonds. Is now you have this new C. So if I had one C and I put it here, okay? If this wasn't a double bond, so I'm covering up this bond, and I move it here, and that's not a double bond, is that the same structure as I just had a second ago? If there's no double bond there, that's just a single bond? Was that the same? Yes, but with a double bond, is this the same as that? No. So if you get a double bond, that's like there's more stuff I have to worry about. So just be mindful. If I give that to you, I'm probably going to give you a smaller formula. So as the bond chain starts to shrink, things speed up really fast. You just got to take your time. And I'm going to be very mindful about that. It's going to be in the range of like 4 to 12-ish. Like it won't be more than that. You'll probably a safe bet that it's probably not the max of what I'm giving you. Just FYI. Only because like if I give you the max, then that's exactly what has to be. So if you make a mistake, then you're like, wait a minute, I can't go further. Like last time I gave 12 options and it was 8. Like that's a healthy buffer for you to be able to feel like you have that freedom of moving things around one way or the other. So I'm going to let you work on this one. I'm going to do the first one. So what do? We have to make the carbon chain. So I make you just do carbons, okay? So I'm going to do the first one, and I made it that one. Now maybe that's not the way you would have done it. I'm going to make you draw them out, and I'm going to make you give me the names. So you do have to give names. So you do it above it or on the side or whatever. So I would have made the 4 carbon chain. And in this case, I did 1, 4. Last hour, I did 1. Oops, I'm going to give it away. I put them on the same one right away. So your job in the beginning, you're not shrinking the chain for a while. Can you manipulate and move those eyes all around? What I'd suggest, please, don't name the whole thing. We'll do one more just so you can see what I'm talking about. So what else can I do with the eyes? Oh, no. What just happened? Now you see all my secrets. I could do this. Let's just get into this. This might not be the most organized version of this, but what I'm trying to just show you for today, I don't want to stress out about the names. Tomorrow, this would be inappropriate on the test. Can't just do 1, 2 and be like, well, Mr. Gussie, the rest of it's the same. I'm wanting to make sure we get through all of our notes today. So that would be a 1,2 diiodo butane, okay?
You know, you
It's a branch. Yep. So what I'd like you to do right now is come up. I think it's okay to do it like this for today. If you want to just do a ditto mark, that's fine. That is not, again, I'm not trying to show bad practice. That's not okay on the test. So come up with as many as you can. It's in the range of what I just said, like 7 to 12-ish, okay, from before. I picked another one that was similar. It's usually kind of the range that we want to shoot for. So I'm going to pause it if you're watching this at home. So here's some other examples. A 1-3. I did a 1-1. I did a 2-3. All these, again, just have the name diiodobutane because I'm just moving around the eyes. And a 2-2. Are there any other? So 1, 2, 3, 4, 5, 6. Is that all of them for the? I don't want to move down and give out any others away. Did anybody get any more than 6 with the 4 carbon chain? Did I miss any? I might. I don't know. I didn't do it very systematically this time. It is not your job. Do not think that you have to find the exact order I would have done it in. That's ridiculous. I do appreciate that when it's somehow we're on the same, like, oh my gosh, yeah, I moved it this way. But it doesn't have to be like that. I think that's all that you. So then you got to go, you got to shrink it, I believe. Like, I still can't see it. Yep. So if I just cover up these eyes for a second, to shrink it, where is the only place I can put that extra carbon? In the middle. That's it. So I'm going to be limited very fast. Like that's all I can do. Like the minute I'm limited to one option, because if you put on the first or the end, you make a butane again. So by doing that, I'm just going to show you, see if you got any of these. Here's one of them. Very sloppy, I apologize. Let me fix that one. I put it on the first and the third. So that'd be 1,3-diodo, and then fix that. And then my methyl's in the middle, so 2-methylpropane. Somebody had a good question last hour, so I want to just address this. Because that's the only place I can put my methyl, they asked, do I have to put the 2? You know, I've been stating if you don't put a number, it has to go where, like, the first possible place it could be. It is a bad habit to get into and a risky game. You can get away with it, but don't assume that's the rule, okay? This is the only thing you should feel safe on, are functional groups and bonds that are on the first available carbon that it can go on. Anything else, a branch, like this methyl, you number it. Well, it had to be there, so that's why I didn't put a number there. We are trying to be very strict and following our rules, okay? I'm a rule follower, you gotta follow. So that's a 1-3, what else can I do? I could have done a 1-1, and is there any other ones? There's one more. You could have done a 1-2. I know it doesn't look like it immediately, but that middle carbon only has 3 bonds. So then you can do that 1-2. And again, the name's exactly the same for those. This will not be one like this, exactly like this on the test. The reason why I don't love this for a test, but I think it's a good test for you to see if you can have the imagination to move things around. The names are exactly the same over and over and over again. So it's not a great actual test question, but it's good exercise for us to continually move some things around. I'm going to send you tonight one more if you'd like, an isomer, and then I'll have an answer on that link. So if you want to try one more with just carbons, because I think it's good to see, do one. It might have a double bond, it might not, something like that. So if you want to practice one as a fresh problem, I will get back to you at the end of school today, as I'm just thinking about it, because I think that'd be good to have one more. Okay? All right, so the rest of the hour we are naming and drawing, and that's it. And I'm sorry, I'll do the best I can to try to help you figure out how to draw some of these. So away we go. All right, we're starting big. So if you want to draw 5 carbons in the beginning, on that bottom line, there's 3 on top, and then that one coming down, and then that weird looking shape, okay? I would draw these with me. I'd want to be involved. All these things are fair game. As complicated as all these things look, they are extremely helpful to us, to help us for tomorrow, and we can do them all. They're very manageable. So, as we're drawing this, let's continually remember how we approach this. First, I want to find the longest bond carbon chain that I possibly can. It has to follow just a couple easy rules. One, it's always got to include an extra bond, and or it also has to include a functional group. Okay? As long as it does that, I'm good. If it doesn't, then I didn't find the proper chain for our rules. Okay? So if you'd like, box the chain that you're going to use. It's got to include the bond and it's got to include the longest chain. It also has to be able to be named. Like if you have two choices, like, hey, this makes 7 either way, but if I go this way, the branch is really funky and I don't know what that is. But if I go the other way, that's an easy branch for me to name. Well, then you gotta allow the rules that we know to work. Okay? So that would be the one that I would have chosen. Your work is not graded tomorrow, but I'm going to be shocked if I don't see boxes on a lot of things. I will be shocked if I don't see numbers on carbons. And I'm not shocked at this. Those tests that I don't see boxes or I don't see numbers usually don't have as good a scores. It just isn't. And it's not a test of if you can do it without it. Like, I'm going to do all this without writing anything on my structures. There's no award for that. Usually that means no sticker. What is my top, my number one carbon? The top, the first carbon on the top, or the last carbon on the bottom? So is this number 1 or is this number 1? What gets the number first always? What's the priority? Bonds, right? Then functional groups, then branches. Okay? And by the way, they both would be a 2 in the first place. So this is 1. This is 2. This is 3, 4, 5, 6. Let me this is a good opportunity to do this right now. Let's pretend there was another bond down here. Don't draw this. There's another bond down here as well. So then it would have been a 2 either way. The bottom numbering would have been the right way then. Why? Because this branch here would have been a 3 going the other way, right? Versus a 4. If you have a tie, then you got to go to the next step. Okay, what else? What can I make a lower number? But that's not there. So we got to be able to name this. Personally, I think it's smart to put a little letter next to my branches of what it starts with for the word. It helps with the organization. So let's just start with this one. What is this letter? A P. That's a phenol or a phenyl because it's a branch. It's a benzene, but it's a phenyl. What is that? Good. Started off hard. That's an iso, right? That's an iso. That's not a ethyl methyl, like, hey, there's an ethyl with a methyl. It's an iso because it's off the second carbon. Just so you are clear, that would be an isobutyl, right? It'd be off the second carbon, but there's 4 of them. So just keep in mind, if you ever see one that there's like a fork in the road, but clearly it's a branch, your mind might need to go to iso. It's going to show up, I promise. So let's name it. I got to go in alphabetical order, not by numerical order. So I comes first. So it's 4 isopropyl. 5 phenyl. 2 hexene. And as you're kind of looking at that, I can let you draw the next name. That's the name we're going to use. And anytime, please ask questions about the little things, the big things, anything. It's really important. Like that name, it has to be. What I love about this, if you're on, it's the easiest test for me to grade. I mean, if we're all on, you will have these tests by Friday if everyone took it. Like I will grade them on Thursday night. The only reason why you will not have them back on Friday is if they're taking me, if they take some time. Like if there's too many issues. Like if we're all on, or enough of them are on, I can pump these out really fast. So I guess it'll be a sign of whether or not the whole group did well or not, is if you have your test back on Friday. Unless we don't all take it. Okay, if you have a name, you will have to be cued on how I want you to draw it. So it'll either say lines, all atoms, or carbons. So this one, I would have written lines. I am not going to pick something that is harder for you. I'm going to pick something actually that's easier for you. I want you to draw it in the way, using the easiest or the most recommended way of drawing things. So if it's really small, like an ethane or a propane, a lot of times we don't do lines because it's too small. zigzag is not a very effective method. The bigger it is, the more likely I want it to do lines. If I'm just wanting to talk about carbons and bonds, then I'm just going to ask you to do carbons, like an isomer. So in this case, I want to do lines. So we have to go backwards. What do I want to draw first? I want to draw my chain. So I'm looking at this, and there's my chain right there. There's 8. So please, when you're doing this, when you set your pen or pencil down, that's 1. So 1, 2, 3, 4, 5, 6, 7, 8. Excuse me. Okay. Then, I don't care which way you go. If you want to get cute and go from right to left versus left to right, that's your call. But usually I just go from left to right. Now I just go. I just read. So 1, 2, 3, 4. I'm going to put an I. And then on my 1 and my 7, I'm putting a what? Of a bond. So this is 1. And this is 7. Right? Some people will put it there. Because you're thinking 7. That's a 6, right? That's a 6. So I just think what's funny is as long, even as complicated as that name looks, that's it. So let's just talk about it if we went the other direction. When you have 2 bonds or 3 double bonds, let's say, you have to say where they are, just like you would have said it if there was one of them. And then right before the bond, you say the prefix. Okay? So there might be an example in the test if you had the picture. Like if you, last hour we actually did the picture, we went to the name. But after we did that, I'm like, you know what, we didn't do enough drawing last hour, so I wanted to do one this way. So you might be able to find a hint. All right, let's draw this one. Oh, this one was just giving you carbons. I'm going to give you as many examples as I can today of different kinds of things that'll test you. So let's see what this one's all about. Probably a lame question, but why does the carbon on the left have to be number 1? I mean, it has to be. Because there's the functional group, right? I mean, this one, there's no leap here because everything's over on the left side. Now, tomorrow, you do not get a pink sheet. So, it has been consistent throughout whenever I've done organic. The biggest thing is the functional groups people have a hard time with. So, what I want to keep trying to get across to you is that even if you're forgetting what the functional groups are, everything else can be right up to that point. It's just the suffix of what you're using. So you got to still do your best. Don't bail out and all of a sudden all rules fall out the window because you don't remember what that is. So first, 1, 2, 3, 4, 5, 6. So I have 6. So this is on 1, 2, 3, and then that's my 6. So I have a 3-ethyl. I'll get there first. Right, that's an ethyl. There's 2 coming off. And then I have 6. You can say 1 if you want, which I was about to, but it's on the end, so you don't need to. If you did, it's fine. So I have 6. I would say hexan, and now it could be oic acid. It could be hexanol with an OL for an alcohol. It could be hexaloate for an ester. But this is my friend sitting on the edge with lava shark waiting for him. His name's Al. Al's in trouble. What? Yep. Al's about to die, and we're going to have to pump him with formaldehyde. Oh yeah, aldehyde. Aldehyde. Hexanol. For that, if you make a sloppy A or a sloppy O for your alcohols and your aldehydes, you are just asking for potential problems. You can't be like, well, that's clearly an A. Like, or that's clearly an O. You cannot stand in the middle. Like, you're done. Like, you're going to open yourself. If I can't tell, I will mark it off, and you won't be able to talk me into it because it's clearly. I will look quickly to see how you make another A or another O, and that could be your fate right there. You're like, oh shoot, you really don't do your O's very well. But if it looks like you do, obviously, right? If I do an octa somewhere else, well, I got you one way or the other. Like, I'll know what you did. So hopefully you are consistent. Oh yeah, that is supposed to be your A. Great. Good. And that's it. That's the name of that one. So aldehydes are on the end. No, that. Okay, another one. Just so you understand this one, I have 1, 2, 3, 4 peaks here if you're trying to do your zigzag. Because I know it's hard to copy it down. I get that. So I give you a line. Can you give me a name off of that? So, you get something like this, again, I expect not necessarily box, it's harder to box it is really hard to box zigzags, but you can at least number the zigzags. If you don't want to box a zigzag, you still can, but you should at least number the zigzags, okay? Off of the chain, I still think it's really important to put letters on my branches. I want to organize my branches. So I want to organize the the alphabetical order. Hopefully we have the alphabet down. I'm hoping I'm not hearing someone humming L-M-N-O-P. Like we're in trouble. Okay, I got it. You have like a bromine and a fluorine and you're like A, B, like you're singing the first part. To be honest, once in a while, this is sad. I do have to, like if I'm trying to figure out like X's and V's and W's, I sometimes have to sing the ending of the alphabet. Just, I mean, like if you're like, we'll put like 3 different random letters in order. Like, I'm embarrassed. I said it, I'm admitting it. Here we go. Let me ask this. A or B? Is that carbon 1? A. Is B a carbon? No. Okay. I just want to make sure that we have that down, because sometimes you doubt ourselves. If there's a line and at the ending of a line there's something written, then that's what's at the ending of that line. It's not a carbon any longer. That's 1, 2, 3, 4, 5. Now, be very careful. When you get to the end of a chain like this and it branches off, I would make sure I just count it. Even if you're like, I got it, there are ones that have 1 extra one. So I go 1, 2, 3, 4, 5, 6, 7, 8, 6, 7, 8. Okay, they're the same. If they're the same, you can do whatever you want. I try to keep it, if it's exactly the same, keep the chain visually as a chain instead of having it branch off. So this is what, if you saw my test, this is what I would have to make sure I don't make mistakes, because I know how I am on tests. I make the mistakes on the things that I can control. It's not the stuff I don't know, it's the stuff that I just mess up on. So that's what I do, just to make sure I organize it. So now I visually see that, and now I go. And I'm not going to worry about the functional group yet. So I have, let's see if you got this right. I hope you've been trying to do it without me. I have a 6-ethyl, 5-fluoro, a 3,4-di methyl, and you put it in order. It's not a 4,3, it's a 3,4. I ran out of room, so you just put a hyphen, or you put a hyphen at the end. I don't care which way you did it. You did it here, that's fine. Then I can just start, whatever. And then my chain is 8, so I have an octa again. Octan, and then it's, I mean, if it was an alcohol, it'd be octanol. Aldehyde, octanol. Same thing. If it was an amine, octan, amine. In this case, it's an octanoic acid. Okay? You got to try to remember. I think the acids are the hardest part. Is that? Oh yeah, wait. If that H is, whoops. If that H disappears, and I would add an extra zigzag to that, Esther wears glasses. That's what our lab's about. I'm making esters. So I'm stripping off of an H off of an alcohol, off of an acid, and I'm adding an alcohol that got its OH stripped off, and that's why it made water. Morgan?
Did you need a hyphen after dimethyl?
No, I didn't actually.
Or did you
No, you're right. You're right. I'm falling into some old habits. I was taught sometimes between the branches and things and the actual chain itself. Even in some books, you'll have a hyphen. If you did do that, it wouldn't be wrong. The things I'm concerned about, are you putting a hyphen between a letter and a number, and are you putting the commas between that? I also put the hyphen, to be honest with you, there because I felt like, because I finished the lines kind of like writing the word. So that's how you could also argue that. But let's just say you mess up your functional group. My gosh, look at all the other things you have to do. You have a 6-methyl, 5-fluoro, 3,4-dimethyl. You had to use this prefix, right? Little things like that. When you're done, please, before you move on to a problem tomorrow, double check that when you wrote 2 numbers or 3 numbers, did you put a prefix? Just double check that. Because that is the single biggest mistake I constantly see with students. And it's amazing how easily students mess up your numbers. You're going so fast, and all of a sudden you look down, you see your number, and then all of a sudden you're writing it to the methyl instead of the ethyl or the floral. So just be careful on that. Okay. Oh, shoot. I erased the wrong thing. Hopefully you didn't see it. You probably did. Butylpropyl ether. I want to draw one. We don't draw enough today. So, what do you not see in there? What's absent? What's a huge thing that's not in that? There's no chain, right? And there's no numbers. Right? No chain or no numbers. So, what that tells me, that's a huge hint, and hopefully right there that already stimulates the idea of what's happening. And if you're like, it doesn't for me, that means that something else is taking the place of the chain. That means something else is connected, is connecting everything. And when I see these YLs, those are considered just branches, right? So what are they connected to? Well, they're connected to an ether. And I hope the way that I taught it, at least it'll spur your mind. Esther wears glasses. Oh yeah, the glasses were O's. Oh yeah, esters and ethers. Oh yeah, so the ether is also an O. So the first thing I want to draw is an O. Okay, so I'll give you a second to draw this. This would be a classic one to draw lines. So butylpropyl. Why is it written like that, by the way? Because of the B, then the P. Right? Maybe you didn't. My question wasn't very specific. That has to just be in that order. Okay. So give it quickly. Draw it if you haven't already. It doesn't have to be on the left or the right. My gosh. In fact, I'm going to go against the grain and do the opposite just to show you that it wouldn't matter. So be very careful. What did I just draw there? A butyl or a propyl? Yeah. People, when they put their pen down in here, sometimes they accidentally say 1. That's touching the O. So that's the butyl, and I'm being difficult right now. I'm sure that you all drew, if you did this right, drew it on the left side, but I'm just wanting to show that you could do the other way. Doesn't matter, right, at all. So that's what it should look like, or the opposite. But you just have 2 branches off of the O. And that's all. Okay, so there might be if there's an ether or something without chain branches, great. Okay, let's do that one. We're going to do the name. But, sorry, I'm going to change it just a little bit because I don't want to repeat things. I probably didn't change anything for you. So let's start with this thing. When you have zigzags, besides writing numbers, sometimes it's important when you have functional groups to actually draw C's. Not always. Again, your work is for you. It's not for me. I want to see your answer. So, where's carbon 1? I mean, that's actually, like, if we start out right beginning of this whole chapter and I say, tell me where the first carbon is, you won't even know what I'm talking about. Like, we've evolved a lot. Where is carbon 1? Right here, right? That's carbon 1. So that is a carbon. And sometimes just writing that one's important. For that and esters, this one and esters, it is based on a carbon. It is housed on a carbon. So carbon 2 is here, 3, 4, and 5. Okay? What are these other 2 in general? Like, what is this viewed as? It's an ethyl, so it's a branch, right? It's a branch. So I'm going to name that first. Why is that the branch and not over here? Because this is my actual functional group because it's bonded to that carbon, and it has to be sitting on, bless you, on the chain. The functional groups have to be on a chain. So it's not a question of, it's on the left or it's on the right. It has to be there. So this is an ethyl. So I have ethyl. I don't need a number. When things are bonded to a functional group, there are no numbers. So that's another big hint. If you see a name and there's no numbers, there's nothing to say because it's not on the chain. So that's ethyl. And then I have 5. So I have pentan. Notice I'm always kind of ending that. If you miss one letter here or there, that's fine. Obviously, some letters are more important than others, as we talked about. Well, I put a Y, and it was supposed to be an E. I misspelled it. No, you did a triple bond and then a double bond. That has significance. If it was an alcohol, I'd say pentanol again, right? If it was an acid, I'd say pentanoic acid. If it was an ester, I'd say pentanoate. This is pentan, amine or an amide, right? Because of the O, right? Amine is low in the name, so there would just be an H. Like this right here would be ethyl pentanamine. That's pentanamide. So you just write the whole name. Remember, amines and amides, full name. I remember amine and amide because ammonia has N in it, and it sounds very similar, or similar enough to me.
Can you go over how you
No.
know one's the branch again?
Because this part, that C, it's bonded to that C. So the functional group is on, like if I redrew this, if I redrew it like that, it's bonded to this carbon. I had answered the same question, that's why I forgot the reason. So that, it has to be bonded to the chain. So this is the chain. So then anything else on here that's all chain.
So like the longest one.
No. So, okay, if I did this, if I did this, just making this up. Well, let's get weird. What's the name of this? 1, 2, 3, 4, 5, 6, 7. Oh, I want to go 8. This would be octyl propan amine. Because that is still, it's bonded around this C, so that has to be the chain, and anything connected to that C is the chain. Anything on the other side is the, and it's not about being on the right. It's about how these two, the N and the O, are bonded to that C, so it has to be bonded onto the chain. So octylpropanamide. You don't get that too often. All right, a couple more. We're doing really well. Let's go. Just so you know, just again, 4 peaks. It's easier for you to do it then. There's 4 peaks in that center area. Get them all down. I don't want to say a thing. Can you name this or get as close as you can? Good luck. I'm gonna pause it out. I just want to ask this: is carbon 1 on the left or the right? The right? Carbon 1, left. Those are the options. Is it? Let me ask this: is it dictated by the functional group in this one? For this, it's not, because if I go either way, I believe it's a 4, isn't it? 1, 2, 3, 4. I'm sorry, 5. 1, 2, 3, 4, 5. So, if it doesn't matter which direction on the bond, that's what I always ask first. Oh, there's no bond, double bond or triple. Oh, it's not dictated by the functional group. I got to keep going down the list. There is a right and a wrong way, unless if it's all tied. So what does it go down to? That one, right? Because that's the low. If you go from right to left, that bromine would be the 3rd branch. But if I go here, it's the 2nd, and that's what I have to do. I mean, you gotta appreciate that that's a lot simpler than having to like take them all, averaging them all out. I mean, my gosh, that would be horrible. Your goal is the lowest number first number that you can get. So that's my numbering. Don't ever underestimate that. I don't want to have this lecture coming back or on Friday. I've had this in groups in past years. How many people, how many tests I saw over and over again with 0 writing on their structures, and it resulted in really poor grades. Like, we do really well all the way through this chapter, and then all of a sudden you guys all become superstars and don't want to write anything on there. Like, you think you don't need to. I think it's really important. And if you don't, that's great, but I'm shocked on tests. I'm also shocked when you have bad scores that you didn't do this. I mean, if you have good ones, that's fine, but keep straight. If you're good with it, fine, or if you're circling it, or you're really thorough one way or the other, that's fine. But you just want to make sure that you're keeping track. So this is the name you should have come up with. I put a hyphen there, but I can't see it too well, so I'm not meaning to do a double hyphen. I just now can't erase that. Then, I have a functional group on 5, so let's just start in the beginning. I have a 4,7-dibromo, 2, 3, 6 trimethyl, and I'd go back when you have multiple ones just to make sure you put them on the right number after you wrote it. 5 functional group, 9-carbon chain, so nonan. If it's an alcohol, it'd be nonanol. Carboxylic acid, nonanoic, which wouldn't be in the middle. But this is a nonan-one. Nonanone. I don't know how you're going to remember that. A ketone, I remember a key in the middle, maybe one man standing or one person standing. You want to be sexist? By themselves, there's only one of them. But the hard part is like an aldehyde, although they're very similar. An aldehyde is a ketone, but on the end, and it can't be the same. So that would be 4, 7, dibromo, 2, 3, 6, trimethyl 5, nonanone. Okay, almost done. We're going to go a little bit faster. So write this down. I'm going to give you the name right away. We just have a couple more I have to draw. I've been talking a little more than I did last hour. These are our last 3. And then I just want to quickly talk about how we're going to draw something. So I got to get over to the PL2 room in a second. There are 8 C's on the bottom here, and there's 4 on top here if you're drawing that, just so you get it. We're going to fly through these last couple.
When you're doing functional groups and like there's like one on the end, like does it have to go on the one? Like it has to go on for sure.
It has to be on the one, unless it's a bond. There's a bond as well. Let's say let's just make this up a long chain, and a bond was on one end and a functional group was on the other. Then the functional group's on the end. Okay. That's on the on the end, like the last number, and the bond gets the first number.
Okay.
Yep. I know when I first threw that out there, a lot of people were like, "Oh my God, I got to remember that order." But for the most part, I don't feel like that's a huge issue anymore. Bonds, functional groups, branches. Okay, I'm going to number this right now. So, guys, numbering. This is a C, right? And this is a letter-wise an E, right? Okay. It is, I will not mark this wrong tomorrow, but it is best practice if you have a choice and it's the same numbers. So what are these numbers going to be in general? These aren't 1s and 2s. 3 or 4. If this is 1, 2, then that would be 3 or 4 or vice versa, but this has to be a 1 and a 2 one way or the other, right? It is good practice if you could have 3 or 4 or 4 and 3 to give the lowest, or the first alphabetical letter the lowest number. I would not mark it wrong, but it would be good practice to do so. So this would be my numbering. I'm just saying that today, so I would not feel like I would have, like, that's fair if I grade it like that. But this would be 3-chloro, 4, because the goal is to get the exact same name always. So this is the name for this one. 3-chloro-4-ethylcyclobutene, right? The double bond always has to be on the 1. But the double bond cannot be between the 1 and the 4. I need you to, right? That can't be. You could not have made your chloro or your ethyl a 2. That's not right. Okay, let's talk about this one quickly. And I'm sorry, we're kind of rushing this at the ending, but you gotta make a bond, the chain, including all of your bonds. So by doing that, I just sacrificed length of the chain, right? The chain could have been longer, but it can't. Which one is my 1? There is a right and a wrong. Right or left? Why, Tyler? Good. The next double bond would have a lower number, correct? 1, 2, it's on a 3. If you go the other way, by the way, it would be a 4. So, what I have here is a 5, this is something I haven't written yet this year, a 5-pentyl, right? That long thing is a pentyl. Then a 1, 3, 6, hepta, how am I ending that? Triene. Last thing I just want to talk about, I'm just going to draw these 2 out for you. Right here, if you're drawing stuff out, like on the ends, I'm just going to show a really shortcut to this. That would have 3, this would have 2, this would have 3. So anything in the middle always has 2. Anything on the ends always have 3. So the fact that these don't have 2 tells me something. That is a double bond. So where's the double bond between what carbons on here? between 2 and 3. So this is simply 1, 2, 3, 4, 5, 6, 7. This is a 2 heptene. That's it. That whole thing written there is just a 2 heptene. All right, and then I could ask you stuff. I'm just going to draw these out. A dehydrogenation of this would be something like this. You could draw something like that. You could do anything you want. A halogenation. To have a halogenation, you need to have somewhere to add it. So it could look like this. And then a substitution, finally, would look something like this.